All right, this is going on page 140 when we are done. And we're going to look at vectors from an algebraic perspective, which we really kind of started on Friday because I didn't want to do just the geometric perspective with you. And so here is a vector in standard position on the coordinate plane, right? Do they always have the, is this the head or the tail? What this, head or tail? That's the tail. This is the tail. The initial point is the tail. Is the tail always at the origin? No, okay? But in standard position it is. And when it's just floating out there, if you think about it in standard position, it kind of helps you picture where it is and what is going on, right? So this is in standard position, and in standard position, then the actual vector itself, this represents which value? Is it x or y? But that's my x value, right? So this is my x value. This is my y value, right? If we're thinking about this being on a circle, this represents, you can think of r as the radius when we're talking like unit circles, but it's also the resultant vector. And so what r actually represents is that. And what does this mean? It's magnitude. So r is the magnitude of the vector that is r, right? And magnitude is really just means what? Length. Okay, it's just the length. That's all it is. So this vector, whatever it is, vector r, I can represent like this, x, y. So y'all told me that in physics you don't really ever represent vectors in an ordered pair notation. Is that correct? Yes? Okay, so that got me thinking, like, then how do you represent them? Like, what, do you just talk about magnitude and direction and you don't really look at it as an ordered pair? Is that what's happening? Okay. This right here, then, remember, is called the component vector. Or it's the component form, basically. All right, so we're going to look at taking this, the component form, and from that we're going to find the magnitude, which we represent like this, right? That means the magnitude of r, and the amplitude, which, what does the amplitude mean? What's the word that y'all really use? Because I don't think you really have used amplitude before. Direction. Means what kind of information or measurement is it? Positive or negative, but what is it that I'm measuring? Is it going to be like in feet, inches, or what is it? Okay, but what would the units be? Like when you're finding direction, if you're going to have the magnitude and the direction, you weren't using them as ordered pairs. That means you had a length, which could have been like feet. It actually could be miles per hour and stuff like that too, but amplitude tells you the direction. What's going to tell you the direction? The degrees. It's the angle, so it's theta. Right? Direction tells us which way we're leaning. So to start, we're going to find the magnitude. Remember, that's what magnitude means. And our other word for magnitude is just length. Okay. So let's go back to, I don't know, 6th or 7th grade, and let's think about this. If I have the component form, this one right here, and I want the magnitude of r, then what can I do to find r if I have x and y? Pythagorean theorem. Does that make sense? That's all it really boils down to be. So whether I have a picture or not, this is always in xy form. So I know then that x squared plus y squared equals r squared. That means then that r is equal to the square root of what? X squared plus y squared. Does that square root just knock the squareds off? No, it does not. And so another way to look at it, I mean, this is kind of, because r does represent the magnitude, but the magnitude is the square root of x squared plus y squared. You wouldn't have to write it both ways, just whichever one kind of applies to what you're doing and makes the most sense at that point. You're good. Okay. All right, so then we're looking for the amplitude, which is our theta, which is also the direction. Okay, so look back up at the picture. If I know x and y, what can I do? How can I use x and y to help me find theta? Sine or tangent? I heard both. Tangent. Now, if I knew r, could I really use any of them? Yes. But let's say I didn't really care about the magnitude first and I was just looking for the direction, so all I really have is x and y. Then I have x and y, that's the opposite and adjacent, so I can use tangent to find theta. Does that make sense to you? So down here, I'm going to say that I know that tangent of theta is equal to y over x, opposite over adjacent, which means that theta equals what? How do I move tangent? Tangent inverse, okay, of y over x. Every time. Okay, but that's the y, if you want to think about a picture so you don't forget, which one goes on top or if it's x or y or whatever. But now I want you to think about, remember when we did inverses, for tangent, we used quadrant 1 and quadrant 2. This was our positive and this is our negative. When you do tangent inverse on the calculator, it's only going to give you quadrant 1 and 2 angles. That's it. Does that make sense to you? Like, that's the only answer that you're going to get. Is it possible that your angle really needs to be in the second or third quadrant? Yes or no? Is it possible to have a second quadrant angle? Yes, or a third, right? So maybe the angle I really need is in the second or third quadrant, but the calculator, when I do the inverse, is only going to give me first and second quadrant, right? So tell me something about all the points in the first and fourth, and in the first and fourth quadrant is all that they're going to give me. I don't know what just came out of my mouth. It's only going to give me first and fourth quadrant angles. That's the only thing that the calculator is going to give me. It's possible, though, that I think I just said the wrong numbers. Is that why I was looking at crazy? Okay. I'm sorry. Let me back up. I have no idea what just came out of my mouth. So the calculator only gives you these two. That's why I drew them. First and fourth. That's all it gives me. Is it possible that my angles would be in the second or third quadrant? Yes. Okay. So even if my angles are supposed to be over here, the only thing the calculator's spitting out to me are these two. Does that make sense to you? All right. So tell me something about all of the points in the first and fourth quadrant. What do they all have in common? Positive x, right? If my x is positive, my angle is going to be in the first or fourth quadrant. End of story. Does that make sense? That means that no matter what, the calculator is going to spit out the right answer for me if x is in the first or fourth quadrant. So I know then that simply theta is equal to the tangent inverse of y over x, and that's it, and that is when you have a positive x. Now, when it spits out, no, I'm really in the fourth quadrant, it's going to give me a negative angle that we would like to fix and really talk about it as a positive angle. So if it gave me like a negative 30 degrees, how do I get the positive form of that? Negative 30, what's the positive angle that's the same angle? Positive 330, right? So that's just negative 30 plus what? 360, yeah. Once you get your negative angle down in the fourth quadrant, if you just add 360, it gives you the correct positive angle, okay? So now let's say that we want our angle to actually be over here. Then I have to take what's here. Now, since all of these have a positive x, all of these have what? Negative x. So to fix these answers that they give me and make them into the correct quadrants, all you have to do, theta is equal to the tangent inverse of y over x. You have to add 180, and you do that when you have a negative x. Okay? So when you look at your vector, if your x is positive, it's the tangent inverse, and it is what it is. If x is negative, you add 180, and it puts it in the correct quadrant for you. Okay? And you can always double check, like when you're done and you get your angle, you should know what quadrant you were supposed to be in based on the vector that you were given. That's pretty easy to find out. And then the angle that you get, see if you think it's in that quadrant or not. And we'll look at that when we do some examples. Okay? Everybody okay so far? So that's when we're given the vector, and we want to find the magnitude and the amplitude. So let's say that we are given the magnitude and the amplitude, and we want to find the vector. So I'm given the magnitude, which is denoted like this, and the amplitude. So I'm given those things and I need to find x and y. So if I am given theta and I'm given r, is that enough information to find x and y? Yes. Using what type of process? Sine and cosine, using trig, right? So if I took the cosine of theta, right, so the cosine of theta would be equal to what over what? Adjacent over hypotenuse, so that is x over r. Just like, remember when we did that with unit circle and we learned that cosine theta was x over r? And sine theta is equal to what? Y over r. Like that hasn't changed, it's the same thing. And if it's a unit circle, that means the radius is 1, so that's why x is your cosine value and y is your sine value. But we're not necessarily just using the unit circle here. So now if I take this and I solve for x, your x value is r cosine theta, and your y value is r sine theta, just by solving. Easy enough? That means your resultant vector is simply r cosine theta, r sine theta. And we already know it's cosine for x and sine for y, but we're not in the unit circle. So basically, it's like taking the radius and multiplying it by that to get the actual value. Does that make sense? We all good so far? So those are just taking it in two different directions, depending on what information you're given. Okay. All right. So let's look at the 3 ways to represent a vector. First is the component form, right? So my vector looks like this, right? Component form is that ordered pair with the pointy brackets, x, y. Right? Linear form, what does that use? Do you remember that from Friday? We used some extra letters in there. Remember what they were? I and J, yes. And I want to add something to that. This is one of those things that you can denote in a couple different forms, all right? And then, but after talking to, and even your textbook doesn't even use this form, I think it might like refer to it, but I don't know that it doesn't use it in everything, and even some of the other textbooks. But once you start actually applying this calculus-wise, and maybe in physics and stuff too, because I really do need to sit down with a physics teacher and make sure that we're aligned with this stuff. But I know for sure for calculus that you start kind of talking about it a little bit differently. So we're using I and J. So let's just go ahead and write it like we did on Friday. So you just take the x value, and that goes with which letter, I or J? I. So this would be whatever my x value is, I, plus whatever my y value is, J, and that's the linear form. So the difference, or the thing I'm going to add here, are these little hats. And so we really talk about them as I hat and J hat. Okay? Because what else have you used the I in? Yeah, the imaginary numbers, right? And so in the side of the textbook, it says, don't confuse this I, and they don't use the little hats, this I with the I for imaginary numbers. Because the I for imaginary numbers is bolded in italic, and this one is not. I'm like, well, okay, how do you really show that when you're writing? Like, that's very confusing. But it's I hat and J hat, and that's the way you say it. It's like a little hat. And you may not see it in everything you do. I did make sure that the homework got retyped that way. It means the exact same thing as what we did on Friday. And again, you'll see it like this sometimes, and sometimes you'll see it different, but I do want you to at least know what I hat and J hat is. Okay? All right, thank you. All right, everybody good with that? Then we have the trigonometric form, and I want to remind you that R, it just represents the resultant. Okay? We're going to write two different things here, because you can see it this way. The resultant times cosine theta, sine theta. Right? And that is your scalar multiplication, where the resultant is the scalar. So the actual trigonometric form ends up being R cosine theta, R sine theta. And it's not like you have to write it like this and then get to this step. You could see it both ways. You're more likely to see it this way, though. So I just want you to know that that really means the same thing. We all good with that? Any questions? Okay, so now we are going to find the component form and the magnitude of the vector AB. So since it is vector AB, do we know which one is the head and which one is the tail? Yes. So it's like a array, right? You start with A and you end with B. So the head is B, the tail is A. And that makes a difference when we go to find the component form, right? So for vector AB, to find this, in this one, I'm going to write out the steps. It's okay that you don't write them out every time, but I just want to make sure that we all understand where this is coming from. It's very simple. It's just head minus tail. So this is -9 minus a -2, comma, -1 minus 7. So what's -9 minus a -2? -7. And -1 minus 7? -8. Are y'all capable of adding and subtracting positive and negative integers? Yes. Do we ever make a ridiculous mistake with that? Yes. So you know whether or not you need to actually write this down. Because the mistakes happen when you're like, I don't need to write it down. I can totally do it in my head. And then you do something ridiculously wrong. So be careful with that. So this is, oh, not AR, sorry. AB. This is vector AB in the component form. Then I need to find the magnitude. So the magnitude of the vector, okay, that's just equal to the square root of x squared plus y squared, right? And that's using these numbers here. This is the square root of -7 squared plus -8 squared. What happens when you square a negative number? It becomes positive. So think about that when you're, typing them into the calculator and things like that. But this is the square root of 49 plus 64. What's 49 plus 64? 113. So then the square root of 113, which really from the very beginning, you could have done all this on the calculator because you're not going to be able to give me a decimal for 113 out of your head, and I know that. But so the magnitude of AB is equal to 10.630. Easy enough? Good. Just got to make sure you know what's being asked of you here. Any questions? All right, let's go ahead and look at this second one. So on here, the vector in component form is just the head minus the tail. So 9.4 minus a -4.3 and -6.2 minus 1.8. So what do you get for the x value? 13.7. Good. That's positive. And then what about the y? -8. And that is vector AB. So when you're thinking about what quadrant that's in, it's not necessarily what quadrant it's in. It's what quadrant would the amplitude or the direction angle be in. And if you picture it at the origin, which is not necessarily where it actually lives, right? Then what quadrant would this direction angle be in? In the fourth, right? Because you go to the right and then down, so it's pointing down here. So my angle is down here in the fourth quadrant. Right? They didn't ask us for that here, but I just want you to, that's how you think about which quadrant it's in. You can kind of picture it in standard form. All right, so then we want to find the magnitude. So that is very simply the square root of x squared, 13.7, plus -8 squared. And you can type all that in your calculator. My suggestion to you would be don't even type in the negative. You know it's going to be squared and be positive, so if you type the negative in wrong, which sometimes happens with parentheses and stuff, you're likely to get the wrong answer. So even though I say, a lot of times you don't want to do a whole lot of work as you're doing it so that it just does it for you, that might be one thing that would actually help you not get the wrong answer. So what do we get here? Good. 5, good. 15.865, and that is the magnitude of AB. By the way, I just want to say, I put in the test grades. I don't think I took off from a single person 1 point because you didn't have units or anything else. Like, I didn't have to do that. So y'all are doing that, and that is fantastic. These examples don't have units on them, but they could. And so make sure that you're putting them there when it's important. So you're doing that, and you're doing a great job of that, so just keep that up. Okay, let's look at this next one. Then I'll let you practice on a couple too as we get through it. But this one, this is your scalar multiplication, and it is just as simple as it looks. You are literally taking the vectors and substituting them in here for what we have. So vector H is -6, 2. Minus 4 times vector F, which is 8, 0. Plus 5 times vector G, which is -3, -5. So I'm really just going to be adding and subtracting, but before I do that, I have to multiply first, right? So I'm just going to rewrite this -6, 2. Instead of leaving this as minus, I'm going to make this plus and distribute the -4, right? So what's -4 times 8? -32. What's -4 times 0? 0. Plus 5 times a -3 is -15. 5 times -5 is -25. So probably the mistakes that are going to happen here are on signs, because you can add, subtract, and multiply, right? It's going to be a ridiculous sign error, which I made myself twice on here. So when I look at my x's, I have -6 and a -32. That's -38. And then along with that, a -15. What's that going to give me? And you can use your calculator, just make sure you're using it correctly. $53. I know, it's okay. I had the wrong, no matter what I did, and I picked this specific problem for the notes so that we would have to distribute a negative, and I kept telling myself, and every time I made this positive, I did it like twice, and I kept getting that answer, and then I was like, what am I doing? And then I put 53 and didn't put my negative. So it's so easy to mess up on the easy stuff, believe me. But it is -53. And then for your y value, what do you get? -23. And it's that easy. Okay. Everybody okay with that? Yes? All right. Let's look at the next one. So this next example says, write vector DE is a linear combination of the vectors. So what does that mean I'm using? The linear combination is I hat and j hat. So linear has an I in it. That's your whole I hat and j hat thing. It's going to be better for you to do if you get the component form first. It doesn't ask you for that, but that's basically where your I hat and j hat is coming from. So vector DE in component form would be -7 minus 9. What does that give me? -16. And then 2 minus a -6 gives me 8. So that's my component form. That's not my answer, but I use that to get my I hat, j hat. You with me on that? So that means what that's going to give me is -16 what? I hat, then plus 8 times j hat, or 8j hat. This is your linear combination. It's just a different way to represent the vectors. Just like the component form is a different way to represent the vectors than what you have seen in the past. Not that we're not doing that at all. There's just different ways depending on what we're using them for. Okay, are we all good? Any questions? All right. So now this says find the component form of vector v with the given magnitude and direction angle. All right. So I'm looking for v. When you're given the magnitude and the amplitude, or the length and the direction, That's when we have that cosine and sine thing going on, right? If you're not sure, if you don't remember what to do, you can draw yourself a picture and figure it out from there. But it's very simply just r cosine theta, r sine theta. So this right here is your r, this is your theta. So this is going to give me 4 cosine of 135, 4 times the sine of 135. Everybody good with that? If it is a special angle, it needs to be an exact form. Is this a special angle? What's your reference angle for 135? How do you find the reference angle? Subtract it. Yeah. So what quadrant is this in? What quadrant is 135 in? 2, which means to find the reference angle, I take 180 and subtract 135. What's 180 minus 135? 45. Is that a special angle? Yes. So using my little hand trick, what's the cosine of 45? Square root of 2 over 2. What's the sine? Square root of 2 over 2, right? So then you have to decide, since you're in the second quadrant, which one of these two, if any, are negative? X, okay? So it could be one, could be the other, could be both, could be none, right? But in the second quadrant, your cosine is negative. So what this ends up giving me is 4 times a negative square root of 2 over 2, and 4 times, and sine is positive in the second quadrant, so that's positive square root of 2 over 2. Calculator's not going to give you the exact answer there, okay? We good? And I think you've gotten really good at your reference angles and your special angles in radians, but we also have to recognize them in degrees, which seems so much easier to begin with, but it's actually a whole lot easier to recognize them in radians, and then you just kind of have to learn which ones to be looking for here. So the vector then, what's 4 times a negative square root of 2 over 2? Negative what? 2 square root of 2. And then your y value would be positive 2 square root of 2. Everybody okay with that? So I want you to do this second one on your own. I'm going to give you a minute to do that while I go check roll. Is 125 a special angle? No. So you don't know what that value is, so it doesn't have to be an exact form. So this is one where you can just type it into your calculator, right? And since the angle is 125, does that kind of tell you, if you think about this as a coordinate point, what quadrant that point should look like it's in, right? We're in quadrant 2, so we expect a negative x and a positive y, and you get what for x? Good, negative 8.604, and for y you get 287. Everybody okay with that? Any questions at all? All right. So now let's look at this one. It says find the direction angle of each vector to the nearest 1,000th of a degree. Okay, so this gives it to me in I hat, j hat. I would rather look at this as the component form. I know both of them are new to you, but I think the component form probably makes a little bit more sense. So if I look at the vector in component form, that's just going to be what? Negative 2, 5. Right? So there's your component form. If I want to find the direction angle, or the amplitude, what do? Tangent inverse, right? And so if you need to draw this in standard position to get your mind wrapped around it, do that, but that's all that's really happening, is that theta is equal to the tangent inverse of what over what? 5 over negative 2. Okay, yeah, y over x. So is it just that, or do I have to do something else? What do you notice about your x? You have a negative x, right? So this should be tangent inverse of this plus 180. And before we add 180, we're going to write this stuff down. So once you take the tangent inverse of 5 over negative 2, what do you get? You get negative what? Good. Negative 68.199. But here's the thing. It's not just that this is negative and we don't want it negative. This is actually itself the wrong angle. Because that is a quadrant 4 angle. Where am I supposed to be? If I have this. It's supposed to be a quadrant 2, right? So if I'm in quadrant 4 and I'm supposed to be in quadrant 2, how do I get there? How far is that of a rotation? 180. That's why you add that 180. It puts it in the correct quadrant for you. Okay? And then that gives you that theta is actually equal to 111.801 degrees. Okay? That's why you add the 180, because it's taking you 180 degrees around to get it in the correct quadrant. We all good with that? And it'll work that way every time. And if you're supposed to be in the third quadrant, you'll get a positive angle. And then you have to take that and rotate it 180. So either way, whether you get positive or negative, you add 180 because it'll get you in the quadrant you're supposed to be in. Okay? All right, so you do this next one while I pass out the homework. Okay, is that what you got when you did the tangent inverse? Okay, so is that the wrong angle? Is it really the wrong angle, though? It may not be the good form, but it's not the wrong angle, because look, up here, we knew we were supposed to be in the in the second quadrant, but it gave it to us in the fourth quadrant. Here, it gave me a fourth quadrant angle. Where am I supposed to be? In the fourth quadrant, right? So it really is the right value, but we prefer to talk about them as positive angles most of the time. So in order to get the correct form, not that this is the wrong angle, what do we do with this number? Add 360. So you can add 360, and that just gives you the positive angle, and what do you get? Good. So in this case here, this is not wrong, just negative. Okay, so wouldn't be the end of the world if we used that angle, because it would still get us in the right place. And these two things here, these are the same angles as opposed to the one above it. And that's not something you do every time y is negative. Every time x is negative, you add 180. If the only negative is y, that's when you do 360. If they're both negative, the fact that x is negative tells you what to do. That's why I didn't give you another rule for that. I just want you to think about where it's supposed to be. Okay? Yes, sir. Yeah, I actually want you to put both of them for me. Yeah, so like here, that's a good question. I actually want you to put both of them for right now. Here, both of these are not an answer. Like this is just the wrong angle, and this gets us in the right place. This is the same angle either way, but just go ahead and give me both of them when it comes up. Okay? Does that make sense? We good? Any questions at all? Awesome. All right. So go ahead and glue that in.